Okay, I'm going to model verifying trigonometric identities. The easiest methods we have are using substitution, and so I have 3 examples I will show you. You really need to memorize all the trig identities to be able to do these efficiently, and you have to understand basic math, and that's where a lot of students are going to struggle. I'm going to prove that cotangent x multiplied by sine x is equal to cosine x. When you're doing trigonometric verification, I personally would rather students work on one side of the equation, and I set these up so students can work on the left-hand side of the equation till it equals the right-hand side of the equation. On difficult problems or in other areas, you might need to work on the right side first or work both sides. But for everything we're doing in this class, we're only going to work on the left side of the equation. So I'm going to go ahead and just draw a dashed line between the two, down through the equal sign. And I'm going to do the work on the left-hand side and then explain what I did on the right-hand side. So I always have to look at where I'm going. I want to end up with a cosine x, so I know I want to get rid of the sine x. And I know that cotangent x is cosine over sine x, so that's what I'm going to use. I'm going to replace cotangent x with cosine x over sine x. And that's still multiplied by sine x. And the reason I could do this is the quotient identity. The quotient identity states that the cotangent of x is equal to cosine x over sine x. My next step is when I multiply these two, the sine x in the denominator and the sine x in the numerator equal 1. So I can cancel those out. So I just have cosine x left, which I was able to do because of multiplication. That's my answer. So this is what I want to get to. This was only 2 steps. Another example would if I had secant x times cosine negative x minus sine squared x equal cosine squared x. So once again, I have to look at where I'm going. I want to get to cosine squared x. I'm going to put a line down through here. Well, I know secant x I can make into cosine x. So that's the first thing I'm going to do, is I'm going to change secant x to 1 over cosine x. Everything else stays the same. To do that, I use my reciprocal identity. Reciprocal identity is 1 over cosine x is equal to secant x. Cosine negative x, we're not as familiar with those, but you're going to use them every once in a while. That's your even-odd identity. Cosine of negative x is equal to cosine x, so I can replace that. So I have 1 over cosine x multiplied by cosine x minus sine squared x. And I used an even-odd identity. Now when I multiply 1 over cosine x multiplied by cosine x ends up with cosine x over cosine x, which is 1. So I left with 1 minus sine squared x, and I multiplied. Still looking to where I want to go. I want to go to cosine squared x, but I don't have a cosine squared x. But I do know that a Pythagorean identity is sine squared plus cosine squared is equal to 1. So I can replace 1 with sine squared x plus cosine squared x. And that's a Pythagorean identity. Now I look at this, I have a positive sine squared x and a negative sine squared x. When I add those, it becomes 0. So sine squared minus sine squared x minus sine squared x, 0. All I have left is cosine squared x. And I use the additive inverse property. That's exactly what I wanted to get to. So cosine squared x equals cosine squared x. That one's done. I'll show one more. If I have sine pi over 2 minus x over cosine pi over 2 minus x equals to cotangent x. So once again, draw the line down through the equal sign, and I'm only going to work on the left-hand side. Looking back at my identities, sine pi over 2 minus x is equal to cosine x. And cosine pi over 2 minus x is equal to sine x. That's called a cofunction identity. Cosine x over sine x is equivalent to cotangent x. So I can replace cosine x divided by sine x with cotangent x, and that is my quotient identity. And that's what I wanted to end up with. So cotangent x is what the ending was. So there are 3 examples using substitution to verify trig identities.